folks, how are you doing? So today we want to talk about some common formulas for a given variable. First we want to look at the distance, rate, and time formula. We have distance equals rate times time. If you'll notice a key to the right, D represents distance, R represents rate, and T represents time. So I have a formula or a problem for you here. Trina walked for 2 1/3 hours at 3 miles per hour. How far did she walk? So the first thing we need to do is break down all the information that we have and identify what is what. So if she walks 2 1/3 hour, we know that that's going to represent our time. She walks 3 miles per hour. That's going to represent our rate. And the question is, how far did she walk? And that is going to be our distance. So if we write down our formula, distance equals rate times time. We're looking for distance, so I'm going to keep that as distance. Our rate, remember, is 3 miles per hour. So we put in 3 for our rate. And our time is 2 1/3 hours. Okay, so when we multiply that together, we have to multiply 3, which is a whole number, times 2 1/3, which is a mixed number. And the problem is we can't leave 2 1/3 as one is a mixed number. So when I have 2 1/3, if you'll recall, you can multiply 2 times 3 is 6, and then add the numerator to get 7/3, and this is what we call an improper fraction. And you would much rather multiply fractions with improper fractions than you would with mixed numbers. So when I multiply 3 times 7/3, it turns out great actually. This 3 over 1, these 3's cancel, and I get 7. And remember, 7 is distance, so 7 miles is my final result. Now I do want to spend a minute and talk about units. If you'll notice when I put the 3 in for miles per hour, the way to write miles per hour is miles per, means a fraction bar, hour, and then the 2 1/3 is hours, and that would be hours. And if you'll notice, when I multiply these unit fractions together, the hours cancel because one's in the numerator and one's in the denominator, which leaves me with my final answer of miles. So for example B, we have another problem here. Distance equals rate times time. You may want to pause it and try this one on your own. But we have Rachel is 168 miles from Chicago. If she needs to be in Chicago in 3 hours, at what rate does she need to drive? So again, let's highlight all of our information. She is 168 miles from Chicago, so that is likely a distance. She needs to be in Chicago in 3 hours, so we know clearly that is a time. And it's asking at the end for rate. At what rate does she need to drive? So we're missing our R information. So if we do distance equals rate times time, you can either immediately solve for R right now, or you can just substitute in the information you already know. So for example, what if I wanted to get the R by itself right now? Then I would need to remove the T. And since we are multiplying by T, to remove the T, I need to divide the right side by T. And if I do it on the right, I must divide the left side by T as well. Now on the right, the T's cancel, if you'll notice, and you're left with D divided by T is equal to R. You can think about that as a brand new formula. D divided by T is equal to R. So when I solve for R, I can plug D for my numerator. Remember, that was 168 miles. I'm going to use the units this time so you can see what happens. And T is in hours, and it's 3 hours. Now, does 168 divide by T? By 3, let's find out. And I get 56. And remember, the units for rate is miles per hour, which is exactly what we have right here. Nothing cancels like it did in the problem before. So this is our final answer. So let's try another problem. Maria is driving from Miami to Orlando at a rate of 65 miles per hour. So that's important information. We'll go back to it in a minute. The distance is 235 miles. And to the nearest tenth of an hour, how long will the trip take? Okay. Now let's label everything that we know. A rate of 65 miles per hour, we know that's R. A distance of 235 miles, that's D. And how long will the trip take? We're looking for time. So start with the formula you know. Distance equals rate times time. But this time, we're looking for time. We're trying to solve for time. So what we could do is solve this equation for time by getting rid of the R. Now that R is being multiplied times T, so to undo multiplication we divide. If we divide on the right, we're required to divide on the left as well using those properties of equality. So the R's cancel. So I have D divided by R is equal to T, or time, and you could write it the other way. T is equal to D divided by R. And then you can plug in. So T is equal to D. Remember, D was 235 miles divided by R, which is 65 miles per hour. So first, let's just do the math part. 235 divided by 65. We can do that in our calculator because it says that we are allowed to round to the nearest tenth of an hour, so to the tenths place. And now let me show you what I get. I get 3.61538461 But if I round to the tenths place, the 6 is in the tenths place, right? We look directly to the right, so all of this doesn't matter. That number is below 5, so we do time is equal to 3.6. Now let's talk about the units, because that looks a little odd. We've got miles in the numerator, and that's divided by miles per hour. Now you remember how to divide by a fraction. Remember, you flip it. So it's miles times hours per miles, because I flip this fraction upside down and multiply, and the miles cancel to give you hours. Now we anticipated that. Time was in hours. So all this fraction work here that I'm doing with the units is not required. But I do want you to see that it works out. So you do calculations with units just like you do calculations with constants. So our final answer is it takes 3.6 hours to drive from Miami to Orlando. Now question D is actually asking us to solve for something we've already done. It's asking us to take the formula distance equals rate times time and solve for R. So what I'm trying to do is isolate that R. So I don't want to do anything with R. I want to do something with, I want to get rid of the values that are being multiplied or divided to R, or added or subtracted, which is not in this case. I got to get rid of that T. So since it's being multiplied by the R, to undo that, I'm going to divide by T, and I have to do it on both sides. So those T's cancel. So my result on the left-hand side is D over T, and on the right-hand side is R. And if you'd like to rearrange the sides, you certainly can. That's the same as saying R is equal to D over T, or distance divided by time. Now for our next example, let's talk about a new formula. It says use the formula A equals 1/2 BH to solve for B. So for this next problem, we have a new formula to take a look at. We have A equals 1/2 BH, and it asks us to solve for B, but then we have two problems below. The first problem says to solve for B when A is 62 and H is 31. And the second problem says solve for B in general. Now if you have to do both of these, to me it would be easier to solve for B in general first. And then you could solve for B when A is 62 and H is 31. We'll take a look at that, but what if you didn't notice that? I want you to see it is okay to just jump in. Notice it says A is 62, so I'm going to remove this A and replace it with 62. It also says H is 31, so I'm going to remove this H and replace it with H is 31. So let's do that first. So I have 62 is equal to 1/2 B times 31. Now what I want to do is use my commutative property of multiplication and go ahead and multiply 1/2 times 31. You know that 31 is over 1. So I have 62 is equal to 1/2 times 31 is 31 over 2 times B. Now I'm trying to solve for this B, so I want to leave the B alone. What I'm trying to get rid of is the 31 over 2. So to remove 31 over 2, I need to multiply both sides by the reciprocal. So I multiply the right by 2 over 31, and I multiply the left by 2 over 31. I'm going to rewrite that so you can see it. So I have 2 over 31 times 62, remember that's over 1, is equal to, now what do I have on the right? Well, the 31's cancel and the 2's cancel. I'm just left with B, which was the point. Now I do notice that 31 and 62 have common factors of 31. So 31 goes into 31 once, goes into 62 twice. I have 2 times 2 is 4 in the numerator, and 1 in the denominator, and 4 over 1 we know is just 4. So B is 4. Now again, I'm going to revisit that in just a minute, but let's solve for B in general. So if we're just given the formula, A is 1/2 B times H, and we want the B by itself, then what we could do is first let's get rid of the 1/2. So to do that, I'm going to multiply the right side of the equation by 2 over 1, the reciprocal of 1/2, and the left side of the equation by 2 over 1, which is the reciprocal of 1/2. Now again, if you'll know why I did that, because the 2's cancel and the 1's, and I'm just left with, on the right, 2 over 1 times A is just 2A. And on the left, I just have B times H. Now remember, we're trying to get the B by itself, which means I need to do something with the H. I've got to get rid of H. To do that, since it's multiplying times B, I'm going to do the opposite and divide. Okay, so I divide both sides by H. The H's cancel, and I get a final result of 2A over H is equal to B, or I could write that as B is equal to 2A over H. Now if I revisit my problem number 1 here, when they asked us to plug in 62 and 31, if I had already solved for B, then I would say B is equal to 2 times A, which was 62, over H, which is 31. Okay, 31 goes into 62 twice, and you get 2 times 2 is 4. So that is a much easier solution, but you'd already done the hard work over here when you solved for B. Now, I know you might recognize this formula, A equals 1/2 BH. That is the area of a triangle. So base times height is the area of a rectangle, and if you take half of a rectangle from corner to corner, you get a triangle. So that's 1/2 base times height. Now I have another formula here for you. This is called the simple interest formula. So if you're calculating interest on a certain amount of principal, P is principal. So if you were to calculate interest on some money, that would be the amount of money you're calculating interest on. So say, for example, you owe money, and you say borrow $500, and they use simple interest to calculate it. That $500 is your principal amount. The rate is a percentage that we're going to have to change to a decimal to use this formula. And it is how much interest is charged on the principal amount. And T is time, and it's typically in years. And that's how long the money will be charged interest. So we're supposed to use the formula I equals PRT to find the principal P. So again, notice what they're trying to do. They want us to solve for P. Okay. The first problem, it says when I is 5,400, that's your interest. R is 12% and T is 5 years. The second question just says solve for P in general. Let's solve for P in general. I think that'll be faster, and then we'll go back to the first question and find out what P is when we substitute in. So if I have the formula I equals P times R times T, and I want to solve for P, that means I want to leave the P alone and get rid of the RT. Well, the question is, what is the RT doing to the P? Well, right now it's multiplication. So to get rid of it, we're going to do the opposite and divide. Can I divide by two variables at the same time? Sure. That's not a problem at all. So this R cancels with this R, and this T cancels with this T. Now, write down what you have left. So I have P, and I'm switching sides on you, so this is this P, equals to the fraction I over RT. So we've already done part 2. We solved the formula for P. It's the same formula. It's just to solve for P instead of solve for I. Now if we go back to the first question, then we can easily just plug in. If you'll notice, it says I is 5,400, so I'm going to put that here. R is 12%. So I'm going to put that here, although I'm going to change it to a decimal first. And T is 5 years, and I'm going to put that there. So I have P is equal to, again, I is $5,400 divided by R. Now, I can't leave it as 12%. When you change a percent to a decimal, you remember you move the decimal 2 places to the left. That's a few videos ago. 0.12 times 5 years. And then, just use your trusty calculator and type in 5,400 divided by. Now, if you're going to enter all this in your calculator at one time, you need a set of parentheses. So I'm dividing by 0.12 times 5, but I need parentheses around that. So 0.12 times 5, and I get 9,000. Remember, that's a dollar amount. So $9,000 is our principal. So for question G, it says solve the formula 5x plus 2y equals 18 for y. They want us to get the y by itself. Now the first question, it says do it when x is 4. And you could go ahead and plug in x equals 4 straight above and then solve for y. Or you could do the general question first and then go back and plug in x equals 4. Both methods are appropriate. You're doing some of the same work if you do the first question and then do the second question. So I like to do the second question first. So I'm trying to solve this equation for y. So let's write it. 5x plus 2y is equal to 18. So what I'm trying to do is get this y on one side of the equation by itself. It's called isolate the y. Now to do that, I'm going to have to do something with this 5x, and I'm going to have to do something with this 2. What I don't want to do is touch the y. Leave it alone. So if I want to get rid of the 5x, I need to subtract it on both sides to get it to disappear. Remember, you can do it once on the left side and once on the right side. Okay? Now the 5x's cancel. I have 2y equals. Now these are not like terms. The best I can write that is 18 minus 5x. Okay, I can't combine that together to get 13 because the 18 does not have an x. These are not like terms. Now I want to divide by 2. So I divide the left side by 2 and I divide the entire right side by 2. So my answer is y equals 18 minus 5x all divided by 2. Now when I go back and do part 1, I'm going to substitute x equals 4 in for this x right here. And so I have y is equal to 18 minus 5 times 4 over 2. And order of operations means I have to simplify this numerator first. And even within that, I need to multiply before I can subtract. So it's going to be 18 minus 20 divided by 2. We know 18 minus 20 You can either think about using your properties of of integers, and you have to change your subtraction to addition, change the sign of the next number, so 18 plus a negative 20. Or you can just imagine you have $18 in your checking account and you write a $20 check. So you are 2 in the hole. So minus 2 divided by 2 gives me a final result of negative 1. And remember, that's y equals negative 1. So for h, we're having to solve the formula P equals A plus B plus C. Now this formula reminds me of the last formula. Let me go back real quick. That 5x plus 2y equals 18, that is not a special formula for anything. I'm sure we can make up a word problem where that would apply, but that's not like the other formulas where we did simple interest, or we did the area of a triangle, or distance equals rate times time. This is just a random, what we call linear equation that they gave you. Same thing with this one. I could probably say P represents perimeter and A, B, and C are side lengths of a triangle. That would work, but it's not necessarily a formula for that, but it would work. They want us to solve this thing for C. All right, so I'm trying to isolate this C. So the first thing I'm going to do is rewrite the problem. I have P equals A plus B plus C. I want to leave this C alone. I want to get rid of the A and the B. So let's draw our line through our equal sign. So let's get rid of the A first. The A is being added to C, so to undo addition, I subtract. All right, so on the left, I don't know the value of P and A, so I'm just going to write P minus A is equal to, now on the right, the A's cancel, and I still have B plus C. Now remember, the goal is to get the C by itself. So I don't want to do anything with C. I want to do something with the B. How do I get rid of it? Once again, I subtract. Okay, so this B and this B cancel. So on the right, I have what I need, which is C all by itself. And on the left, I can't subtract B from P minus A because they're not like terms. So the best I can do is write P minus A minus B. And that's my formula. It's C is equal to P minus A minus B. And that's the final result. Now once again for I, we don't have a special formula here. 5x plus 8y is equal to 1, but we're asked to solve for y. So we want to isolate this y on one side of the equation. It's probably worth pausing the video real quick just to make sure you understand this. So what I'm going to do is I'm going to rewrite my problem. 5x plus 8y is equal to 1. And keep in mind, I'm trying to move everything away from this y. I'm trying to get rid of the 5x. I'm trying to get rid of the 8. Now you have to ask yourself, what is the 5x doing to the y? Well, it's being added. So to undo addition, we subtract. So I'm going to subtract 5x from the left side, which means I'm required to subtract 5x from the right side as well. The 5x's cancel, and I have 8y is equal to 1 minus 5x. These are not like terms. I can't say 1 minus 5x is negative 4x because the 1 doesn't have an x. Okay, so that's the best I can write it. Now again, trying to get the y by itself, which means I've got to do something with that 8. Well, right now the 8 is being multiplied by the y, so the opposite operation of multiplication is division. So I'm going to divide the left side by 8 and the entire right side by 8. So that long fraction bar is required. So I have y is equal to, now in the numerator I have the entire expression 1 minus 5x, and in the denominator I have 8. And that is our final answer, 1 minus 5x over 8. So I have two more of these examples for you just to get you used to solving an equation for a variable. They're often called literal equations where you solve an equation for a variable. But this time I have a common formula for you. P equals 2L plus 2W. P stands for perimeter. And the 2L and the 2W just means the sides of a rectangle. So where L would be the length and W would be the width, and if you traveled all the way around, this would be L plus W plus L plus W. In other words, 2 L's plus 2 W's. That is just the perimeter, or the distance around a rectangle. Now, we're not asked to know that. All we're really asked for is to solve for W. So that's what we'll do. So I want this W by itself on one side. So P equals 2L plus 2W. So I don't want to do anything with the W. What I do want to do is remove the 2L and remove the 2. The 2L is being added to 2W, so to undo addition, I'm going to subtract, and I have to subtract the same value on each side of the equal sign. So on the right, the 2L's cancel. On the left, the best I can write is P minus 2L, and that equals 2W. The next step is I got to get rid of the 2. Well, right now the 2 is being multiplied by the W, so to eliminate multiplication, I divide. I'm just trying to get rid of that coefficient of 2. So the 2's cancel right here, and so my final answer is W equals, I'm just switching sides, my numerator is P minus 2L, and my denominator is 2. So if I had information about this rectangle, like what the perimeter is, or the distance all the way around, and I knew the length, but I didn't know the width, well, that formula would find it for us. And this is our last problem in the video. Solve the formula V equals L times W times H. This is a common formula as well. V represents volume, L is the length of your figure, W is the width of your figure, and H is the height. It would find the volume of a box. Okay? Alright, so we're supposed to solve this thing for L. So I'm trying to get this L by himself on one side. So I'm going to rewrite my problem. I'm going to try to rewrite my problem. V is equal to L, W, H. Again, leave the L alone. Don't want to do anything with the L. I just want it to be on the right side all by itself. What I got to do is get rid of W and H. Now remember, that's multiplication, right? Because if there's nothing between a variable and another variable, that's implied multiplication. So to get rid of multiplication, I divide. So let's divide this side by W and H, and there's nothing wrong with dividing by both of them at the same time. So on the right, this W cancels with this W, and this H cancels with this H. So we have what we want. We have L on the right all by itself. What do we have on the left? Well, we're supposed to simplify, but that's not going to simplify. That's just as good as it gets, and I can write my final answer as L equals V divided by WH. So what does that mean? It means that if we knew the volume of our rectangular box and we knew the width and the height, we could find out what the length would be with that given information. I hope you have a great day.